Today we're going to add a Quill speed handle to the new milling machine. Now this one almost worked right out of the box. Welcome back to Cloud 42, I'm James. If you follow the channel, then you know we're breaking in a new milling machine, and today we're going to add a Quill speed handle. It's something that I've had on other milling machines that I've used, and it's something that I really miss, so we're going to add one. This is the stock Quill handle on the PM935 milling machine, and you use it to run the quill up and down. And like most milling machines that come with a fixed handle like this, you have a hub that's on the pinion shaft that drives the quill, and it's got a series of holes around it, and there's a pin in the handle that engages those holes. And then there's a little spring-loaded ball detent that engages these two grooves so that once you snap it on, it will stay in position, and you can pop it out, rotate it to a different position, and lock it back in. And the reason for this is because the handle's not always in a convenient place. So this is great if you're like drilling and you're right up here, but what if you come down here to your part and you're trying to drill in this position? Well, you can just move the quill handle to a more convenient place. But actually switching this is a little bit cumbersome. It kind of binds a little bit here, and the ball detent, I've played with it. You can adjust the strength of it with this set screw. It doesn't work great. I would like to be able to just pop it cleanly to that next position without accidentally popping it all the way off. And it's a little bit cumbersome because of the way it ends up binding. You can tighten it down so that it will lock into that position, but then it tends to stick, and it's a little bit clumsy. So I've used mills that have what's called a speed handle, and the handle itself just has a lever in it. So you just pull the handle out, move it down, lock it back in, and it retracts the pin automatically. And I'd like to get one of those for this mill because it's very convenient. There, I had to take my hand off of it to use both hands to pop that. It'd be so much easier if I could just bring this down. I want to be right here, just go pop like this, and now I'm back in business. Now there are a lot of different sizes of these hubs on different mills, so let's measure this one and make sure that we get the right handle. That is 1'22". So 1 inch 22 thousandths, and I've got that on my diagram here. And then we need to measure the spacing of these holes. And I want to measure the radius of the hole circle, so from the center to the center of one of these holes, and the easiest way to do that is to get the diameter of the hole circle. How do you do that? Because you need to know center to center. Well, we can use the same trick I used when I was making these trays, and we can use the incremental mode of the calipers to estimate it. So I'll just measure the diameter of one of these holes and then hit 0 on the incremental, and then measure outside to outside across two opposing holes, and that gives us some figure of 1.415 inches. Now I'm going to measure in a couple of different places just to make sure it is consistent. 1.417, that's pretty good. 1.42. So those vary by about 5 thousandths. So I suspect, again, I'm measuring with calipers, AKA guesstimators. So everything's not super precise here, but I'm guessing that these holes are actually drilled as opposed to bored, just because as a CNC operation, it'd be a much quicker way to make this part. So the hole spacing may not be perfect, but I've got enough here for an average. The other thing that I want to know is the distance between the holes. Now we could probably calculate that by counting up the holes, but I'm going to go ahead and just take a measure. As long as we're here, that'll provide another reference. And again, because we have already zeroed out on the incremental the diameter of the hole, I can just measure across inside to inside, and we get 714, 703. Yeah, these vary quite a bit. 702. So we've got 714, 703, 702 for that measure. Across we've got 1.415, 417, 420, and for the diameter of the hub, we've got 1.022. And incidentally, that 1.022 is almost exactly 26 millimeters. So I suspect that's the natural dimension here. Okay, since we've got the dimensions, let's go into the computer and see if we can find a handle to buy that will fit this hub. When I'm looking for parts for a project, often the most difficult part of finding what I need is figuring out what it's called. And I often spend a bunch of time just trying to figure out what terms are used so that then I can more effectively search for what I'm looking for. Like when I was looking for a step-down transformer from 220 volts to 110 volts to run a power feed on my 220 volt mill, it took a while to finally stumble upon the term control transformer. And once I figured that out, then I could search and find these things. So I usually just start with Google and just start with obvious things that I actually know something about, like a Quill handle, and start Googling. And in this case, this actually turns up a whole bunch of stuff. Here's the term Quill feed handle, Quill feed speed handle for Bridgeport milling machine. And that sounds very much like what I want. So I can see this is a Quill handle with a hub and a lever, and there's a little pin that you can just barely see sticking out the bottom, and I can see a bunch of different ones. So I'm seeing this Quill feed speed handle. So if I just go out and search for Quill speed handle, then I get a whole bunch of hits which look very much like what I'm looking for. Now, there are lots of different options, and I think the first thing we need to figure out is what options are there that will actually fit this mill. So if I click in here and look at details, I can see the only real interesting information is this says for most Bridgeport style machines. I have a Bridgeport style machine. Hole diameter 1 inch. Well, we know that the hole diameter on this one is actually 1.022. It's not an inch. That doesn't seem right. So that one doesn't look right. I can look at some of these other ones, like these twin grip ones that I can see have 2 pins. And again, it just says for Bridgeport Series 1, and then there really isn't any more information. This one says it's for Acer Alliance Sharp 2 horsepower. Again, it just doesn't have any kind of detailed information that I could use to make a decision. Same thing here, 1 inch diameter hub, so I know that's not the right one. But there's a bunch of these that they have the names of the machines: Atlas, Clausing, Acra, Chevalier, Bridgeport Series 2. I don't have any of those specific things. We can look at MSC, because I saw some hits come up there. Quill speed handle, and we just get the one from Interstate. Again, doesn't really have any information. Bore size, 1 inch, so we know that doesn't fit. We can try eBay. And eBay has very much the same thing. They've got a 3 handle one. Here's again just for Bridgeport milling machine. I swear I clicked on it. Yeah, there, just for Bridgeport milling machine. Again, no real detail except 1 inch diameter hub. But if we look down here, here are these Clausing, Acra, Chevalier, same thing again. And this one though has some more photos. And this one is the most interesting. Let me blow this up, open this in a new tab, and zoom this up. And there is a table down here of all of their different part numbers with dimensions. And that's something we can work with. So we can start with the bore diameter A here. And the bore diameter we got is 1.022. And A, we've got, that one's too small, that one's too small, 1.026, 027, 027. So I think any of these, 1.026, 1.027, 1.027. So one of these three are likely what we're looking for. So if the hole's 1027 and the shaft that has to go in that is 1022, I think we're in business. That's a 5 thou fit. So it's one of these three. They also have these dimensions C and D, and C is the spacing between adjacent holes and D is the radius. And we know that the diameter of the bolt hole circle, we measured these with different holes, 415, 417, 420. You divide that by 2, you get about 709. And we know the spacing between the two holes is 702, 703, and 714. Those vary a little bit, so a little over 700 for both of those. And if we come down and look at this list, this looks like the one we want. 704 for both C and D. All of the other ones are significantly off of that, 765, 689. So this looks the best. 1027 or 1025 for the shaft diameter, and 704 for both the spacing between the holes and the radius of the holes. So it's this one, part 0370337. So we can actually just go back and search for that. That is HQT. And here's the first hit. And if we scroll down and look at this, there it is, HQT part number 0370337. This one actually has exactly that same image. So this is the handle we want. We should expect that this will actually fit the machine. So I will order one and we'll try it. And the great news is it says it's the last Quill handle I will ever have to buy. That's exactly what I want. And there's the handle. Looks pretty reasonable. A nice plastic ball on the end. Good solid steel shaft. Fits in here, flexes. I figured it would have a pivot. It doesn't appear to have a pivot, and it does retract the pins when you pull it back, and it's got a little lock screw right here. I've used these before, but I don't actually know how they work. Let's take it apart. So I've got the copper vise jaws in here, so I don't have to squeeze very hard. The copper grips on the steel really well. And there's just a couple of screws here in the back. Take those out and try not to let the spring fly. Okay, so it's just a cap. And then there's just a spring that holds the handle down. And it looks like the handle, there's a little roll or spring pin pressed in right there to keep the handle from moving, but still allow it to flex. And then these pins it's like the pins just have a notch ground in them. So it's really just that simple. That pin just sits, it just fits across the side of the shaft. There's enough play there so that as it goes up and down, it can move that in and out, and then they just run in holes. Those are actually fairly precisely machined, because even up here where it's kind of a half hole, it still retains it. So on both sides, so that's pretty precisely machined. And there's a little roll pin just pressed in there. And there's nothing else that retains it. That's really simple. I like that. See if I can put it back together without dropping anything. And you'll note, because I've got the yellow handle here, this is a 3/32 wrench, meaning these are imperial fasteners, which I was a little bit surprised to see, but they are. So that's the speed handle. Let's go try it on the mill. It's a good fit on the shaft there. Holes seem to line up. Tighten this down with a set screw until it's firm, and then back it off slightly. Gotta find the groove. There it is. So it's on there. Works as a quill handle, and I can just go like that and change the position. That is fantastic. So in practice, I would bring this down, whip this around, and they're not. Locks in position there, goes in there, But that, it doesn't go all the way in. I don't know if you can see that gap there or not, but the pins are not lining up. Not there, it goes in there, not there, goes in there. Doesn't go in that one. So there's 1, 2, 3, goes in there, 4. It looks like there's 4 positions here where it won't quite drop in, and they're not all together. So I suspect what we've got going on here is we're running afoul of the fact that those holes were drilled. Which means we're going to need to do some fitting. Make sure that key's in a place where it won't get lost. In fact, we're going to turn that around so the key's on top. Just so it'll stay put and I won't have to go chasing it back in the spring well. Okay, so this is a pretty simple part. Yeah, and looking at it, I think I can see that the holes are not. Yeah, the web is a little bit thicker in some places than others, so some of these holes are a little bit further to the outside. The web here is thinner than the web on the outside of this hole. So I think this is one of those cases where this worked just fine with the stock handle because the pin was smaller and it fit in there, but this has 2 pins and those pins are larger, and so it doesn't fit. It's like it fits nicely there, but it doesn't there. Yeah, and those 2 holes have a thinner web on the outside, which means that the hole is positioned outboard a little bit more and the pin is interfering on the inside edge of that. So how are we going to fix this? I can think right off the top of my head of a couple of ways. I could take these pins out and I could grind them down, throw this on the D-bit grinder and just spin those, take a couple thou off of the diameter of the tip of the pin, and then it would fit in the hole better. But again, we're reducing the strength of that and we're introducing a shoulder on that. I think this part is actually the part with the issue, so we could make a new one, which would be a lot of fun, though if I have the quill disassembled, then I have to do everything with the hand wheel. I could bore these out. .230 thou, which is like 5.88 millimeters. I could get a 6 millimeter end mill and bore those out with that, but that's going to leave a really thin web because we're going to take more material off. Could try to get a very small boring bar and a criterion boring head and bore these out. Again, I'm going to have to line everything up without the quill because I don't have that on there. I think probably the easiest thing to do here is just move the hole or slightly enlarge the hole with a Lipton mill. I think that's probably our best bet and probably the easiest thing to do that will give the best result. Okay, so I picked up a new set of Lipton mills for this particular project. And the files are hard to get. Good files are hard to get. If you go out and look at kind of the usual sources, there are just piles and piles and piles of really, really inexpensive files. You know, they're all made in China, which is fine. They're certainly capable of high quality products, but most of what I'm seeing are not decent. I have a couple of other sets of needle files that are just more or less junk. So I looked around for a while, and these are Nicholson's, which doesn't mean anything anymore. Lots of their products are made in China and Mexico as well. But these ones are actually Swiss made. And so I decided to give them a shot. And these really do look fantastic. So I'll pull the round needle file. These are number 2 cut, so they're pretty fine. We'll see if I need to start with something coarser, but we'll give this a shot and see what it takes to actually cut this. So I'm looking at this, trying to figure out where's the best place to start. So I can see most of these positions fit pretty easily. But that is the first hole that hits a pin that has an issue. So I'm going to go ahead and just mark that with my Sharpie there on the edge. And I'll just mark it here too, just to make sure I can see it, because it's blue on black. And then let's see if we can expand that hole slightly. And just see what happens. And it looks to me like it needs to go down. Okay. Nice. Seems pretty good. And now we're to the next hole. And I'm just going to repeat this and keep working my way around. This file is really nice. It's very, very smooth. Okay, I'm going to keep working my way around, and I'll come back when I'm done. Well, those files just did a beautiful job. They cut slowly and smoothly and rounded out these holes nicely. In fact, to look at them, except for the fact that they're shiny and have machine tool marks going this direction, you wouldn't even know this thing was filed. I might also try to pick up, those are the number 2 cut, I think. Yeah, these are 2 cut. I might try to pick up a set that are a little bit coarser as well, but these are beautiful. Very, very happy with those. If you're interested, I'll throw a link down in the description. But let's give this a shot on the mill. I'm pretty happy with how that turned out, and in the hand it fits all right, so let's reinstall it. That nice and tight. Fit that and find the set screw. Now this set screw is just a normal cut point set screw that then rides in this sort of half round groove. I think it would be better to get a ball tip. You can get set screws that have a ball in the end of them, like a hardened steel ball bearing. I think that would be better for this application. So I might try to grab one of those for the future and maybe put a second one on the other side just to make this all run more smoothly. But honestly, it seems to work okay as it is. So let's find the groove here. There we go. And test it all the way around here. And that's great. So now I can have that up out of the way and come around. If I need to drill here, it's exactly the right position, and I can park the handle out of the way. That's nice. This is actually one of the things about that PM940 that I wasn't super fond of, is it had a Quill handle, had 2 handles to go out in opposite directions, and they're not adjustable. So when I end up with it down here, that's, you know, okay, because there's another handle up here and it's convenient to use. But this handle may be running into the work, or it may be in the way of a camera that's trying to look in from this angle. So having this single Quill handle that I can quickly adjust and put it into another position, I am really going to enjoy that. Nice. Okay, well, that's all I have for you today. If you enjoyed this video, please give it a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.